Hi, I want to welcome you to Realize Live 2020. This session is Solid Edge Practical Synchronous. We're going to look at examples of how synchronous technology can be used to make practical changes to mechanical designs. My name is Melissa. I've been using Solid Edge for almost 20 years now. My background is in mechanical design, and along the way, I transitioned into the role of a CAD administrator. So I've been on both sides of the software, both on the use side and also support. I've been doing presentations on Solid Edge and synchronous technology for 6 years now, both at Solid Edge University and also Realize Live. I've provided content on webinars for Siemens regarding synchronous technology and also published an ebook. I'm a member of the Solid Edge User Council. In 2018, I started Polished Edge Consulting, a Solid Edge CAD administrator business where I offer my clients tailored new version training, custom problem resolution, best practices implementation, and help in learning synchronous technology. Before we get into the details of why synchronous technology is so helpful, I want to share with you that Solid Edge is so much more than just synchronous. The pyramid here shows that the Solid Edge portfolio is offering you everything from the proven draft capabilities that Solid Edge is famous for, all the way up to cloud-based collaboration and next-generation design. With each new release, all aspects of Solid Edge are being improved. New models are added to the portfolio that is making Solid Edge a very robust design package. Speaking of new versions, on July 15th, Siemens is putting on a virtual launch event for Solid Edge 2021. So stay tuned in to learn what's new there. This looks like it's going to be an excellent release. There's going to be more information coming out as we get closer to that date. Solid Edge with synchronous technology enables you to accelerate your model creation and make faster edits. It does that by eliminating the model regeneration, which reduces rework, and it also helps improve product features by streamlining that design process. I want to take a minute to talk about what synchronous technology really means. Synchronous is a direct editing design paradigm. It offers you the flexibility of direct modeling while maintaining that stability of history-driven parametric modeling. To not use it, if you're already using Solid Edge, would be leaving technology on the table, especially because the combination of ordered and synchronous offer a combined solution that is second to none. Synchronous technology is a modeling paradigm that will provide you with smaller file sizes and faster edits. We're going to look at how much smaller and how much faster in a couple slides. But first, let's talk about the fact that it is being constantly improved. Synchronous is not new anymore. It's actually 12 years old, but it just keeps getting better. The improvements that are being made with each release of Solid Edge mean synchronous is more intuitive and more stable than ever before. By using synchronous, you can provide better products to your customers and do it faster than ever. Your engineering team is going to be able to spend their time developing their designs instead of being frustrated with CAD processes that aren't efficient. Past non-adapters, now is the time. You already have synchronous technology. What I want to show you today is that it will work with your existing legacy data. You can collaborate with outside vendors to produce products that surpass customer expectations. I was curious about how much faster and how much smaller synchronous technology was, so I wanted to do some measurements. In a fair comparison, apples to apples, with identical files, they were modeled once in ordered and once in synchronous. And what I found is that the file sizes were smaller by 6, 10, and then 30%. Now, notice that the more complex your file is, the more benefit you're going to get from synchronous technology when it comes to the smaller file sizes. But keep in mind, even if you're making smaller square and round parts, you're still going to have a benefit. And additionally, you're going to notice an improvement in your larger assemblies. There's going to be a time savings there for when you do opens, saves, closes, and especially in a managed environment. Just like the file sizes, with the edit times, the bigger the change, the faster Synchronous Technology was. In these cases, it was 35 to 50% smaller to make the same changes. These were not on consumer products. This was precise machinery. There's a benefit also on edits that are performed in Synchronous Technology that isn't as measurable. The changes that are performed using Synchronous Technology provide an additional peace of mind. You're going to be making your changes at the assembly level. Performing fewer steps to change more parts will hopefully help eliminate the case where, after manufacture, you discover that one of your components did not get updated and was machined as the old design. In a new R&D design process, Synchronous Technology is going to mean that you are able to incorporate changes that's going to take your design past being functional and making it the best design possible. You're going to be able to make those extra changes knowing that you have the time. So Synchronous allows you to make improvements. I'm sure many of you are familiar with the ease of making changes using the steering wheel in Synchronous Technology. On an organic looking part where we're not as sure about dimensions, the changes are impressive, but there's another side to Synchronous Technology that I wanted to share with you today, and that is practical changes to mechanical parts. Here is a rubber roll, a very standard subassembly that, for our purposes, we're going to say has been in our CAD library for years. For our example, we're going to complete a size change. Now, we don't need to reinvent the wheel. There's no need to remodel the part only to make this quick change. Synchronous Technology is strong with Save As with existing ordered files for a couple of reasons. First, we don't need to understand the ordered model's life cycle. Often our legacy parts have a complicated ordered feature tree that grew as they've been perfected. There's nothing wrong with the way the part was developed. Instead, that tree shows us a progression towards the perfect part. With each revision, the part has turned into what it needs to be and nothing more. Second, Synchronous Technology allows us to transition parts into a model that is no longer causing delays while the part recalculates following a dimensional change. Let's take a look at a video that shows us how to make this simple synchronous change. As we watch, I'm going to walk you through the process. First, using a window select, I chose the direction for the change and drug the parts off to the right. It doesn't work. And sometimes when a good ordered modeling designer hits this point, it can be frustrating. Too often, it causes them to immediately revert back to ordered modeling. But a small change to the model is all that is necessary to make the change happen in Synchronous. What we're able to do is go into the ordered model, grab the feature tree, right-click, and say Move to Synchronous. After we do that, we're able to go back to our assembly level, and we can make the necessary change. If what you saw at the beginning of the video is something you've experienced in the past while you were exploring Sync, I hope this example helps you see that just because Synchronous Technology is history-free does not mean it's thought-free. Learning how to use this environment is the same as learning any CAD environment. The more you use it, the better you're going to be at securing important dimensions and allowing freedom on the ones that need to change. Good ordered designers didn't get good overnight. and there's a learning process that helps us create these complex models and make sure that they can be edited in a reasonable amount of time. The point we saw where the synchronous change doesn't happen effortlessly is a reminder that we need to learn synchronous. Without the proper training, the frustration can turn users away from synchronous. The first few models done in sync can contain frustrations like the video showed, but after learning what dimensions to secure and which can change, designing in synchronous becomes effortless. The old adage, practice makes perfect, applies to both ordered and synchronous modeling. When your CAD library contains thousands of ordered models, moving to synchronous can be a daunting task. But as you saw here, a quick change to one of the traditionally ordered models gave us the advantage of a top-down change using synchronous technology. Let's take a look at another assembly. In this example, we're going to change a model that was brought into Solid Edge from another CAD platform. In this example, we're going to make changes to a conveyor that was modeled in another software. The featured tree shows only part copy bodies, and we're going to edit this model without having to do anything other than open it and save it within Solid Edge. So let's take a look at this video to see how this conveyor can be changed. What we're going to see in the video here is the ease of making the change at the top level assembly. Top-down engineering has never been easier than it is now with synchronous technology. We're able to window select the child components, and after Solid Edge thinks for a second about that selection, we're going to enter in a dimensional change of 500 millimeters. Notice that we're not having to go into each of the affected files. They are all changing at the same time from within the assembly. Now that the change is complete, we're going to see that our model has updated all at one time. In many projects, companies collaborate with outside vendors. This can be part of an internal initiative to focus on core technology, or it can be the result of a customer project direction. When we need to interface our equipment with that of another company, the usability of that CAD data is paramount. Being able to verify the locations where the models connect with each other means seamless manufacturing. Synchronous technology also excels with legacy data that was designed in another software. If you're changing over to Solid Edge, you're sure that your existing CAD data is all usable. You can keep designing your product without needing to recreate your old models. All the while, you can populate your library with new models in Solid Edge using synchronous. What we see here is pretty representative of the current engineering field. The innovation that is driving progress right now is impressive. Electromechanical assemblies are being perfected by multiple companies working together to meet consumer demand for an increasingly complex smart product. What we're seeing is above and beyond what any one company was able to accomplish in the past. With Solid Edge, you can use your legacy data from Solid Edge or another software. You can piece that together with new synchronous files, and that's going to join with the models of existing customer equipment and provide you a complete design package. With synchronous technology, there's a quickly realized return on your investment of the time to learn it. You're going to have smaller models. You're going to be able to edit your models faster than ever and free up your time for engineering the best product you can without wasting time on detailed CAD processes. You're going to be able to incorporate supplier and customer models, all using synchronous technology in Solid Edge. Synchronous is easy if you want to learn to adopt it. Polished Edge Consulting can help you get there. If you're a CAD admin, is too busy with day-to-day support, or if you're too small to need a full-time administrator, get in touch with me to see how I can help. When learning to model history free, the time spent on training gets you back up to production speed quickly. Spending a few days understanding how and why Synchronous works will allow you and your team to hit the ground running. I want to encourage you to engage with fellow users and Siemens experts in the Solid Edge community. The link shown here is going to take you to the top level of Siemens community, where you're going to find links to access the blog, the knowledge base, and discussion forums on various products in the Solid Edge portfolio. In the community, you're going to find users asking questions, and answers are quick to come from users and Siemens team members who have decades of combined experience. Whether you have a basic question or something no one has tried yet, there's a team within the community that wants to help. For those of you considering Solid Edge, you're able to try it free for 30 days. You're going to have access to the full version of Solid Edge, where you can experience the fast, flexible design changes, powerful assembly management, and seamless use of multi-CAD data. We touched only on synchronous technology today, but as we saw in the pyramid earlier, there is a lot inside of Solid Edge. If you start your trial today at the link shown, you can explore those other modules and environments like the built-in data management, electrical design capabilities, and scalable simulation. Being able to run Solid Edge on your models and drafts is a great way to verify its strength so that you can make a change confidently. There are a lot of tutorials, and there's a great knowledge base available if you have questions. I ask you to take a moment to complete the short survey after our session. And I want to wrap up by thanking you for taking the time to join me. Please don't hesitate to reach out with any questions you may have. Polished Edge Consulting can help you with your training needs. Please visit my website if you have any questions. Thank you.